here with the new year of 2021. Hope everyone had a safe and happy holidays, and hope everyone is having a great start to their new year's. As you guys are well aware, do not forget the semester. First semester one is not over yet. It does not end till the end of next week. So we still have an extra 2 weeks of the new semester. But with that being said, we're going to continue this YouTube lesson with our water cycle notes here. With our Go Blue. As you can see, again, the only assignments we've got is Unit 4 Vocab 1 due the end of this week. I think we're going to have one more notebook quiz for the semester, and then a notebook check to end the semester next week. So look to finalize things, get the best possible grades as we finish out the semester here. Number one, what process occurs at 2, 3, 4 on the diagram? Again, simply put, got to know the water cycle stages. 2, what percent of water is fresh versus salt water? And 3, most fresh water comes from blank in the form of blank. So again, where does most of the fresh water on Earth derive? Where is most of it found, right? And what form does it take? Let's go ahead and pause the video, and then when you're ready, go ahead and let's find out. Number one, we've got stage 2 up here is evaporation, where, well, not 2. Okay, let's see, 2. 2 is going to be condensation. Again, we've got water is going to be, again, condensing into a cloud. 3 is going to be evaporation, where water, liquid water turns into a gas, also known as water vapor. And 4 is going to be rain, also known as precipitation. So that's your answers for number 1, again, stages 2, 3, and 4. Number 2, guys, only 3% of the Earth is fresh water. Most of it is actually going to be salt water at 97%. So again, very little water is actually fresh. And where is most of it found, guys? Most of it is going to be found in actually the polar ice caps. It comes from the polar ice caps where it is frozen, but this can be a problem, again, frozen as solid ice, because when climate change possibly occurs, when climate change occurs, when things get warmer, what happens to that fresh water? It becomes salt water once it goes into the ocean. So again, water that we know and love and survive on in our lakes and rivers and springs is not near as common as the frozen fresh water that is found in the polar ice caps. Okay, moving on, table of contents is the same as last time. We're going to continue our water cycle notes on page 4. I'm not sure whether I may make this, I'm going to see if this will be 3 days or not. We'll just kind of see. We'll kind of go with timing here and see how it goes so far. But yeah, table of contents is the same. Our first question for our first video of the day is, how abundant is water in the universe? How abundant is water in space? And actually, what I want to do is we're going to go ahead and do not worry. Yeah, let's see. What prevented water drying up on Earth? Yeah. So how abundant is water in the universe? And then 2, what prevented water from drying up on early Earth like other planets? Go ahead and write those questions down on pages 2 or 4. I'm going to play some of this video here. I cannot play the audio, but you guys will have to watch on your own, because last time I played a video with audio, it messed up the video being able to be used for YouTube for different reasons, you know, copyright and companies, this and that. So let's go ahead and load our video and check it out a little bit, see what it's about in regards to water in space. Is it common? Oh, I guess it doesn't work on Internet Explorer anymore, which is frustrating. So we are now, so now they've got Microsoft Edge, which is one of the new browsers here. And these advertisements, I can just never tell. But yeah, you guys will watch this on your own, and you'll see. Okay, so over 70% of the Earth is water. Very little of that is fresh water, though. Okay, and our bodies are made up of 60% water. Okay, but believe it or not, guys, to answer number 1 for you, water is extremely rare in space, okay? Water is more rare than gold, okay? It is a precious commodity that we take for granted every day, but water in space is extremely rare. If you were to take a glass of water into space, it would evaporate immediately. So you guys are going to go ahead and watch the rest of that on your own, okay? To find out, again, what prevented water from drying up on early Earth like other planets. What did Earth have? What made it different? Okay. Again, keep in mind, guys, Unit 4 Vocab 1, these words are listed on your Canvas. This is due this Friday. Again, definition, sentences, and illustrations in written format. Take a picture with your name on it and submit it to Canvas. There is a 10th word that is not listed on this, by the way, so make sure, again, we complete that. Don't forget, guys, on page 3 of your notes, you should have the water cycle drawn out on your notes right now. I'm going to be checking for that on the next notebook check next week. So we should have a water cycle like this drawn out on our sheets. But let's go ahead and let's take a look at where we left off with our water cycle notes. Again, we do not have fill in the blanks, guys, so I'm just going to have you write word for word what you see here. I want to describe and explain a simplified version of the water cycle. Okay, so we'll go ahead and take our time with this. I may not show all of it. Maybe we'll have a third day for a water cycle. We'll just see. But yeah, evaporation, guys, we've drawn it out, we've written it out, but it's where the sun heats a liquid up into a gas, okay, known as a water vapor. This occurs in lakes, rivers, and oceans. As the gas rises to higher levels of the atmosphere, it's going to condense. So those water particles are going to kind of collect together, and they're going to create clouds through what we call condensation, okay? So those are these processes that you'll see here in a little bit, okay? And again, with condensation, guys, when you see a cloud in the sky, what you're basically seeing is a massive cluster of water gas, okay? It's just a cluster of water gas. It's actually very heavy. When I've gone skydiving, I've seen people who've skydived through small clouds, and they get out of the cloud, a very small cloud, by the way. They get out of it very extremely wet, like they just took a shower. Okay, so that cloud it's dense, it's heavy, and it's got a lot of moisture in it. Okay, the water then returns to the ground as precipitation, and then either flows. So here's what I'll tell you guys. You can make this simpler and bulleted if you want, bullet format. But I just found it too difficult between this class and the in-person class to kind of condense it anymore. So if you want to try and condense it more, you can go ahead and do that. But I made it, like, you know, as compact as I could make it here. And if you want to skip certain words and, like I said, make it into bullet format, I'm totally okay with that, as long as I can tell you did it when I check it for the notebook check next week. So it's going to flow after the water condenses. The clouds get too heavy. It's going to rain. It's going to fall to the ground and flow through rivers and oceans, maybe absorb through the soil, eventually accumulating into an aquifer. Okay, so I got another video here getting into what is an aquifer, also on page 2. 2, what is a spring? And 3, what do we use most of our groundwater for? So let's go ahead and check that one out as well. Hopefully it opens up right to Microsoft Edge, because obviously it's getting angry at me when I don't. It's saying, hey, we don't use Microsoft. We don't use Internet Explorer anymore, right? So there is a lot of water underground all across the U.S., okay? Especially here in Florida. Okay, so like there's underground rivers, there's underground lakes that have not been exposed to the surface for thousands to millions of years since the Ice Age. And I got the captions for you guys, obviously. And an aquifer, guys, is basically an underground water bank. It's a bank of water that has not yet reached the surface, okay? So what does that make a spring? Well, a spring is going to be, and we talk about the water cycle, it rains, goes in the ground, right? Saving you guys time. Ice Age water. That's why when you go to spring, the water's so cold, because a lot of it could be from the Ice Age. It's not seen sunlight in thousands to millions of years. But a spring is basically underground water banks that have now been exposed to the surface. Okay, so I want you guys to watch the rest of that on your own to find out. Again, number 3, but an aquifer is an underground water bank not exposed to the surface, whereas a spring is a groundwater that has reached the surface, right? Okay, we'll do our review question at the end here. So evaporation, transpiration, condensation. We should know evaporation again is when water turns into a gas, water vapor. Okay, transpiration is where water becomes water vapor off of plants. So it's just like evaporation, except it happens off of plants. The plants have pores in their leaves. They sweat like humans do. Okay, and in their leaves, they release water vapor. Again, we call that transpiration. Again, feel free to simplify that however you'd like. I'm not going to be too strict when grading the water cycle notes as long as you got most of it, most of the main points, because we do not have a fill in the blank to hand out to you guys, obviously. And then condensation is when water vapor cools into water droplets as we described when it turns into clouds. So go ahead and copy that to page 4. That'll be added to page 4. I'm going to go ahead. I think, you know what, let me check the Go Blue for tomorrow. I think that might be it for today. We'll just see. I'm happy with that, guys. We're going to call it a day with that. Let's go ahead and do a quick card question here. Okay. So that concludes our lesson today. Let's do a quick card question. See what you guys remember here. Give me 1 second. As I set up our question. Okay, let's see here. So hopefully you guys know this one. I think I might have shown this one before, so I don't want to show things again. Okay, I may have shown this before, but it's been since winter break, so I hope that you guys know it again already. Okay, so if you look here for our class, what is going to impact the water cycle the most? Is it A, the atmosphere, B, wind, C, the ocean, or D, the sun? What impacts the water cycle the most? Take a moment, pause the video, and your answer is going to be D, the sun. The sun impacts whether it's a gas. If the sun's out, if the sun's gone, it could freeze into a solid. Okay, so the sun's going to be the most impactful. This is Mr. Campbell ending our YouTube lesson for today. If you have any questions, message me on Canvas. Got to finish the year strong. We have 2 weeks left of our semester. Mr. Campbell signing out.